Welcome back. Thanks for joining us after lunch. I hope that you all get a good rest, and I'm really looking forward to this afternoon's presentations. So this afternoon, we'll start with a talk from Bob Sorensen. Bob is the Senior Vice President of Research and Chief Analyst for Quantum Computing at Hyperion Research, and Bob will present results from a new survey on enterprise use of quantum computing and provide his commentary on what it tells us. And I've seen a few of Bob's talks before, and I have to say, they're some of my favorite. They're very informative. You know, as we're going through this journey and quantum computing is accelerating rapidly, and we're learning, sometimes we kind of lose sight with what's happening in the rest of the broad industry. So this really will help give us a connection for what's happening more broadly in the quantum computing industry. Following Bob, we'll discuss the latest D-Wave technology. First, you'll hear from Mark Johnson, SVP of Quantum Technologies and System Products. And then Emil Hoskinson, who's our director of our quantum annealing products, will come up and give an update. After Emil, I'll be back to give you an update on our Clarity roadmap and LEAP and some updates with our open source Ocean SDK. If you have any questions about the D-Wave technology roadmap, we're going to arrange to do a Q&A afterwards, so please use the orange Ask Q&A button in the bottom left of the virtual conference platform to enter your questions, and we'll have time to answer some of those questions after the technology update session. So I'll be up here sort of playing a dual role as MC and presenter during that time with my colleagues Mark and Emil. And also, we've seen some questions coming in online about a recording. So this is the Miami event, and we've got Qubits Day 1, Day 2, and Day 3, which is the virtual developer day on Day 3 on Thursday. And then we've also got Qubits Japan. So all of the recordings from the Miami conference will be uploaded into this virtual conference platform sometime next week. And so you'll be able to catch up on any sessions you may have missed at that time. And also, after February 9th, they'll all be uploaded into our D-Wave YouTube channel. So you'll be able to catch up on the videos there as well. So with that, let me invite my friend Bob Sorensen up. Let's welcome Bob to the stage.
Sure.
Thanks, Bob.
Appreciate it. Sure. 25 minutes on the clock. All right, here we go. Hi, I'm Bob Sorensen. I'm with Hyperion Research, as Murray indicated. Just want to quickly give a little bit of background here, a little bit of context. Hyperion Research, this isn't a commercial, this is more an explanation of our perspective. Hyperion Research is an advanced computing consulting firm. We look at all opportunities in advanced computing, whether it be traditional HPC or your Cray class systems that, say, HPE develops, whether it be HPC in the cloud, which we're seeing more and more of, HPC for advanced computing in the AI world, GPU powered. We're looking at DNA computing right now, and we also look at quantum computing. So we don't look at quantum as an island, as a separate entity, as an entirely different computing paradigm. We look at it as yet another tool in the advanced computing toolkit. And the reason I feel comfortable saying that is because the functional reality is that's how users see it. They're not quantum evangelists. They are not in this to explore new technology and make sure quantum succeeds. They're in it to solve their jobs. And if something better comes along, they're on that. If something better doesn't come along or quantum proves itself, they're going to be all in on that as well. So that's really our perspective. We look at quantum as part of an overall computational composition in any kind of advanced computing worksite, compute center, whether it be on-prem or whether it be distributed. It's more about getting the jobs done than it is fostering or supporting particular advanced computing paradigm. So let me tell you a little bit about the study that we did. Basically, Hyperion Research, in conjunction with D-Wave, we really wanted to find out what were some of the opinions and impressions, really, of the quantum computing early adopter base, the folks that had already, in some capacity, kicked the tires on quantum computing, to find out what were their hopes and dreams, were their expectations met, what were some of their selection criterion, and what was the process whereby they actually brought quantum computing into their compute environment. What was the chain of events, if you will. The one thing I'll make eminently clear here is, even though I'm using the somewhat Procrustean template for D-Wave, this was an independent effort. D-Wave was very gracious in terms of funding the work that we did, and they stood back and said, go get us some good results. So this is not a presentation by D-Wave. This is a presentation that stands outside the D-Wave influence, if you will. And in fact, when we talk to these end users, we didn't say we were doing this survey for D-Wave or any particular vendor, because we thought that would, in some cases, either bias for or against if some people love quantum annealing, other people love gate, and they're all willing to wrestle about those things. But we wanted to keep it very objective. So I definitely want to say this is as objective as it could be, and at the same time, I have to thank D-Wave for allowing us to do this basically in an objective way to go. So what we did is we went out and we talked to a whole bunch of different companies. And by the way, there's literally no way I can see this. This is really tiny. Can anybody do anything bigger with that? All right, we'll just go with that then. I only just need to see one slide at a time. So as I said, what we really wanted to do is talk to the people. Oh, that's even better. Oh, cool. Oh, look at that. Wow. Now that you're all impressed. So really, what we did is we went out and we wanted to gather stuff from end users. So I'm just going to give you a quick executive summary because God knows if I'll have time to get through everything we did find out. We ended up talking to we contacted 485 organizations. These were potential quantum computing end users. And the only thing that we ended up gating them through was, do you have revenues of more than $50 million? Do you have an IT budget of more than $5 million? And do you have an active quantum computing activity within your organization? If you answered yes to all three of those, then we really wanted to talk to you. Well, the interesting part of this is we wanted to talk to 300 early adopters, and we said, how many companies are we going to have to reach out to based on that criteria? And what was fascinating to me is we only had to reach out to about 485 organizations to get 300 positive responses, which means we had about a 62% response rate. And these organizations came from sectors or verticals that you'd expect: advanced automotive, finance, the internet and software companies, technologically advanced companies that really do have advanced or aggressive R&D budgets as well. So we didn't want to talk to companies that are perhaps more mainstream, that probably don't have a large R&D capability, but still I think that number of 62% is a relatively fascinating one. Of those companies that responded, those 300s, about 34% right now said they're exploring options and monitoring technology in quantum computing. So I don't want to say it's a wait and see attitude, but they really haven't overly committed in some ways. But we did find about 26% of the companies that we spoke to are conducting use case analysis. Some of the things that we saw this morning already are moving in that stage. What can we do with quantum? How can we bring it into our existing computational workload? And about 14% were engaged in what we would call production use. And really, I think what that means at this point is production use is, again, what we heard today about the Peer 300 activity. It's a cloud-based phenomena. You're reaching out to a quantum system that isn't on-prem, not yet, maybe not this year or next year, or not for a few years. But the idea is it's already started to be integrated into your overall production environment. You may not be betting the company on what's happening in that quantum experiment, but it's something that you're actually starting to drive into your production environment. When we asked about the value driver, what got you interested in this? Basically, 1 in 4 respondents say we want to enhance business efficiencies. And that really falls under, I think, the mantra right now about quantum computing is really killing it when it comes to optimization. And so the idea of enhancing business efficiencies is a really important one. What's interesting is we didn't see a lot of people say they were interested in cost savings, which, if you think about it, efficiencies and cost savings are not always the same thing. You can become much more efficient without having to save money. You may be looking at things like sustainability issues or safety or expanding revenues. It's not just about, I want to save a buck. It's about doing what we do better in some capacity, perhaps gaining competitive advantage or something. But what I found interesting was that improving research capabilities and driving innovation, thus combination of those two represented about 1/3 of the responses. So organizations are interested in figuring out what can quantum do for me in terms of making us a more innovative company through aggressive research, expanding the horizons of what our research capabilities are. Some of the organizational drivers that we talked about is we want to accelerate our existing classical workloads, and we want to adopt new quantum computing workloads. And I'll have to tell you, this is going to completely blow my time schedule here. The idea about accelerating existing classical workloads, the time for that is so ripe. We're seeing a confluence of technology and corporate and energy issues in the classical HPC world right now that's making it more expensive and more complicated to continue the performance gains in the classical world. I was down at Oak Ridge when they rolled out the right now, which is the fastest HPC in the world. It's an exaflop system that was mentioned earlier. Department of Energy had to pay $600 million for that particular machine. It took 4 years to design, and they'll probably get maybe 4 years of use out of it. The next system that Energy is going to acquire, even though it's about a year and a half late at this point. It goes to Argonne National Lab, another $600 million system, but that one is going to run at 65 megawatts, which means that during its lifetime, it's going to consume another $300 million worth of energy. The performance gains to move to the next level of classical performance is becoming more expensive, more complicated, and more power hungry. So classical HPC users who are interested in continuing performance improvements are looking to quant to start to deliver some interesting results at higher performance, but also in some cases at a better price. And the one that I think is completely unappreciated at this point is at lower power. We're talking about 60 to 100 megawatt systems in next generation front edge HPCs. Quantum systems right now are still in the kilowatt range, orders of magnitude less powerful, and they scale, power consuming, and they scale in a much more benign way. So I think the idea of, it may not just be time to solution anymore, it may be power to solution. How much energy did I take to get to that particular solution? That's going to matter more and more to end users. It's a big thing here in the United States, but it is consuming organizations like in the EU and parts of the world where users are basically coming to the sysops and saying, hey, if I run this job 10% slower, how much less CO2 can this job produce? They're actually thinking about penalties in terms of, I run this job the fastest, but I consume this amount of carbon. It's going to become a big issue. Power to solution, I think, is going to be a major kick when quantum actually starts to reach a more traditional market stage. One of the things that we talked about is these early adopters we spoke to, these 300. What do you see in terms of the computational workloads that you're most excited about? And the standard ones, which we see this for about the last 3 years when we've done surveys like this, machine learning applications, finance-oriented optimization, and part of that's because the optimization technologies lend itself to that, and we all know that a lot of these financial organizations, there's great potential return on investment for making even small gains in optimizing a process. So they have been able to dig a little deeper in their pockets right now. And things like logistic and supply chain management are going to be key. For anyone who tried to fly after the fiasco with the cold weather on the west in the United States, the thing that was most surprising, of course, is not that airplanes were delayed, but it took Southwest so much longer to respond simply because their software couldn't handle the scheduling with their particular way that they configure their airlines. That was a software issue more than anything else. It wasn't cold weather because everybody else, all the other airlines had it in the bag. So those kinds of things really matter. What right now is the greatest hurdle to quantum computing adoption? When, again, this is based on the 300 end users we talked to. They're concerned most about integrating it into their existing infrastructure. And this kind of proves the point. They want to bring it in and they want to use it and they want to treat it like a black box. They want to treat it like an accelerator, like they went to NVIDIA and they got a bunch of GPUs and all of a sudden certain things ran faster, or they went to multiprocessors, they uploaded certain MPI software. It made their life easier. But right now the problem is quantum computing end users don't have the capabilities to hire in-house experts to make that happen, and there probably isn't enough from the supplier community at this point to do the kind of integration work that these guys are used to. So if I'm an oil and gas company and I want to bring quantum in, I don't have an in-house quantum team that knows a little bit about quantum, knows how to integrate that in my existing works environment. And the quantum computing suppliers may not be experts in oil and gas the same way they're in finance, the same way they're in aerospace. They may not have the same vertical specific expertise that's required. And we've already started to see that kind of be addressed within the hardware supplier sector. We did a survey a couple months ago that looked at why quantum computing companies partner. And we found that the average quantum computing company today, hardware and software supplier, and we did this around the world, talked to about 108 different companies, they have about 2.7 partnerships, and the reason they partner is for access to expertise in quantum computing hardware and software, but also for integration into classical IT infrastructure and vertical specific expertise. So they're really looking to say, okay, how do we become, in some sense, a virtual full service, full stack? And that's not a full stack of just quantum hardware and software. It's full stack in terms of addressing a vertical, addressing classical IT requirements, as well as delivering a quality quantum product. So when we asked about the selection criteria that they chose when they did this quantum computing activity when they brought it on board, it shouldn't come to any surprise after what I just said that sector-specific skills as well as understanding of verticals. We're right up there with ability to integrate. And what was interesting, and this is something that perhaps matters more when you go to a conference where there's a lot more gate model folks out there. End users really don't care about quantum modality or qubit specifications. In some sense, I don't even think they're terribly concerned about qubit count roadmaps. When you ask them, okay, which do you like? Are you a superconducting guy? Are you a trapped ions person? Or how do you feel about photonics? The end users that make these decisions say, I don't care. I want demonstrated performance gains on the end uses that matter to me, and I'm not willing to dig down too deeply into the stack to make that judgment. No one buys an HPC based on the kind of semiconductor components that are in it. So why should we assume someone's going to buy a quantum computer based on their quantum modality? It's demonstrated performance on end use cases that matter. That's where the end users are really living. When we ask them about, okay, you've already been involved, you've had some activity, you've explored, how do you feel about the next 2-3 years in terms of your budget commitment going forward for quantum? And what we saw was about half are looking at measured growth. We use that phrase measured, meaning they're not going to bet the farm on this, but they're looking at 10 to 15% kinds of budget increases until things really start to take off. And the reason for that right now is one of the major concerns about quantum has to do with this issue about return on investment and being able to make that case to a number of C-suite people and the folks who actually write checks within the company. And the problem there is the R. No one can figure out yet what the return is. And the I. No one's really sure about what the pricing models are in terms of what is available through a cloud access model or do we buy on-prem. And by the way, I think that we're going to see more and more uptake on on-prem systems within the next 2 to 3 years. I think that the internet model, the cloud access model, is a great low barrier to entry for exploration of the technology, but I think we're going to start to see more and more companies for a number of different reasons. Certainly government users and organizations that have confidential data aren't going to want that stuff flying around the internet. Certainly some organizations are going to make the financial judgment that if we are pinning the needle on this system and using it 24/7, the economics are ultimately going to drive you to an on-prem installation. And the other one, of course, are things like hybrid quantum classical algorithms. The idea that if you're running a high-speed job and you have an HPC at this end and a quantum computer at this end, and the only thing that's metering the communications between those two in an iterative, truly hybrid application is the time of flight and other delays on the internet, you're going to say, this is not a cost-effective way, a performance-effective way to do business. So I think we're going to see a little bit of growth in the on-prem market, but right now we should all just revel in the fact that the barriers to entry and exploration of quantum computing capability is virtually free in many cases. We heard it today with D-Wave talking about if you're a researcher, you get access to the system. That's generating a whole bunch of enthusiasm that you wouldn't see back in the old days where to kick the tire on a Cray system, you had to plunk down $40 million and clear out half your basement for power and cooling requirements. This is really a great opportunity for the sector. That was my executive summary, and the rest of it gave me about 9 minutes left. I just wanted, this is called a confidence building measure. Who did we talk to and why should I believe anything we said? What I like about this is, as I said, we had the gating thing, but the bottom line here is about half the organizations we talked to were US-based, and the remainder were basically leading-edge quantum adopter nations in the EU. So this is not a US phenomenon. People need to remember that this is not US only. There is not only a vibrant base of quantum computing hardware and software developers outside the US, but end users who are just as anxiously interested in exploring quantum as you see in the US. Think international every step of the way. That's a little bit of the data that we already went over. This is the verticals that we spoke to. We wanted to cast a wide net to make sure that we talked to as many different, what I said, research-intensive kinds of verticals as we could get our hands on. One of the things we wanted to talk about was who were the early adopters. What was the process whereby you brought quantum into your site? How did you convince, what were the key decision makers? So what we wanted to do was target what we call the quantum computing influencers. Who were the folks that actually said, hey, we should be looking at this? And so one of the questions we came up with was, how long of your average work week do you spend looking at introducing new technologies? And what we found is if you want to find a key influencer who was really responsible for bringing quantum in-house, you're looking for someone whose job maybe 1 to 2 to 3 days a week, their particular charter, if you will, is to explore new and emerging technologies, to understand what's going on and explore the space. And these are the guys that are continuously involved in bringing new technology on board. You can see here a significant percentage say this is literally continuously part of my job. And the other guys, the other big high point there, 3 to 4 times a year, that sounds to me like these are guys who weigh in perhaps on a quarterly basis. This is an interesting thing when we asked about job titles of the people we spoke to. And you'll see that it's the usual C-suite suspects, if you will, CIO, director, CTO. But if you look at the rest of it, about half of the folks who are really driving the quantum computing adoption within the sector, they're not quantum folks. We see one quantum computing professional title at about 12%. Everybody else is kind of rank and file, classical IT folks, end users, data site managers. These are folks who are saying, I think quantum is interesting. Let's kick it upstairs and see if we can get some traction on here. So you can't just go out and find the one guy. Every company's going to have a quantum evangelist of some sort or another, but they're not going to be as easy to find perhaps today as they will be, say, in 2 to 3 years when the wiring diagrams have expanded to meet those guys. So let's go right through some of their perspectives. We already talked about this in the executive summary. Enhancing business efficiencies was really big up there. Interesting is that we found that the folks in Europe are about twice as more interested in competitive advantage than the US, where the US sees research as having greater value than the EU. And I think what we're seeing here is a reflection of, in some sense, government policy for quantum computing right now. In the US, it's much more research-centric. In the EU, a lot of the government programs are geared towards driving quantum into specific verticals, automotive, aerospace, advanced machine tooling kinds of things. So the sense of in Europe, it's what can we do with quantum to make our companies better, as opposed to in the US, it's really more about funding research to create a quantum community, which then can reach out to the end user base. And I think that's what we're seeing here. The organizational drivers, I already talked about, performance improving on existing workloads with equal enthusiasm for new applications. What I like is we're not seeing this groundswell of, hey, we have a fear of missing out. Which means we're talking to people who are enthusiastic about quantum. They're not just there because everybody else is there. They're not just looking around because, well, if he's going to do it, I'm going to do it. So I really like the fact that we've seen in the last few years a decline in fear of missing out. And in fact, we're even moving away now from the risk of missing out concept. It's more about, hey, I'm hearing good things about the sector. We should be involved in this if we're not already. As I said earlier, these are some of the applications that these organizations all saw as being important and worthwhile. What I find interesting is that when we gave people, say, pick all the ones that you think apply to your organization, no one was really left out in the cold here. So even though machine learning applications were chosen by half, even the ones that say material design and staffing and scheduling problems were still selected by about 1/3 of the respondents. So the broad applicability here of quantum to address a wide range of company-specific applications and workloads, I think is clearly demonstrated here. When we asked them about, and this chart really speaks for itself, so is your ongoing effort successful? Basically, between very successful and somewhat successful, almost no one indicated that their current efforts was unsuccessful. I put this down a couple months ago, is this a sign of realistic expectations or patent optimism? And I was kind of juggling back and forth. And I really think what we're seeing here is a transition in the sector away from, hey, quantum's neat, let's all climb on board, to quantum is really starting to demonstrate capability at this point, and we need to start thinking about how we can use it. And the expectations have become much more realistic. The time frames, I think, are extending out in terms of when gate model actually hits, or frankly, does it matter exactly when gate model hits? We're not consumed with quantum supremacy anymore, or even quantum advantage. Maybe we're looking at quantum competitive advantage, or quantum applications that are outpace our current classical workload capabilities, but it's not as crazy or frenetic as it was a few years ago when people were saying, hey, if it's not quantum supremacy, I'm not even going to play the game. So I'm leaning now again more towards, I think this is more about realistic expectations than anything else. This just ties into my earlier executive summary that talked about what was the greatest hurdle for adoption, complexity with integrating an existing IT infrastructure, concerns with demonstrating return on investment, limited vendor options. I think as the sector matures, we're going to see more vendor options, more choices, organizations being able to say, these are the kinds of machines we want because this reflects perhaps our workload. In some sense, I think that's a holdover right now to the classical world where everybody wants exactly the machine they need and don't want to pay for something that they may not use. But this is where it really goes down to some of these things about, the idea about what they're really not interested in. And the one that I find, again, most interesting at the bottom there, no requirements for new computational capabilities, only 11%. Turn that inside out, that means 90% of the people we talk to have some sense of they need computational capabilities. It goes back to this slowing of performance, the increasing demands to realize performance gains in classical computers, and that 11% here is a huge opportunity, I think, for quantum to step in and say, you know those jobs that are really expensive and really hard to do on classical? We've got a solution here for you. So when we asked them about what was your selection criteria, because it was the greatest hurdle, their selection criteria said integrate into existing IT infrastructure, overall technical expertise, and vendor software offering. You have to go way down at the bottom to talk about things like qubit modality options, vendor on-prem options. Again, that's a cloud-based model outcome. Qubit specifications and benchmarks and such. Again, this is the end user perspective. They don't want to hear about my qubit versus their modality versus my modality. I'm calling it qubit fatigue. They're all confused, and it doesn't jump to explain to them how their particular critical workloads are going to be accelerated by bringing quantum on board. And I think that's a critical element to think about going forward. So when we asked them about their plans for the future, about 1/3 see aggressive gains, and we didn't define these things. We basically wanted the end users to define what they thought as aggressive. Half are looking at moderate growth, about half are looking at measured growth, 1/3 seeing aggressive efforts. Only a small number, very small number, if you look down at the very bottom, about 1%, say that was probably 2 or 3 respondents, at the total 300, basically said, yeah, we're backing out of quantum. Whatever activity we saw going forward, we're done with. I think that was it. So those are questions, and I've got some other charts here, but the key here is if you have any additional questions, if you want to delve a little more deeply into some of this stuff, just drop me an email. As I said, D-Wave has been very open in me sharing all aspects of this particular activity because they recognize this is a sector that has to have the best information to make the best plans to go forward to optimize the potential of this technology, and I really want to thank them for that. So contact me if you want to talk more.